Product Communications for GM, Choi Sen.
Good morning, everyone, and welcome to GM Empower. It's so great to see all of us gathered in this room to have an important conversation about energy and electrification. Today, you will hear from GM leaders who will share how the technology that we are building in our cars has the potential to reshape energy markets. We have a lot of industry leaders in this room who will talk about trends and how it's influencing the work that we do. Now, you will have time for Q&A, and we've tried to make this really easy for you. So if you flip your badges over, you will see a QR code. You can submit your questions by scanning the QR code. The platform is open now, so there's no need to wait till the end of the program. After the Q&A, it's where the fun part begins. You will be walking through all these wonderful demos in the room, and I'll come back up for some more instructions because, we want it to be a great experience for everyone. Now, one thing to note, the embargo for all content lifts at 2 p.m. So let's get this show started and have this important conversation. I would like to welcome on stage our Chief Product Officer, Sterling Addison.
Hi, everyone. Welcome. Thanks for coming to GM Empower today and joining us this episode. We're living through an extraordinary moment in history. The world is being reshaped by AI as computational demands are placing stressors on the power grid that have no history on the barrel. By the end of this year, it's expected that data centers will consume nearly 5% of all U.S. electricity. By 2028, just 2 years from now, that number could more than triple. This kind of demand is going to force large-scale changes to the U.S. electric grid. And as it accelerates, rebalancing becomes critical. The modern world will need highly decentralized, responsive, and robust power infrastructure to meet the need. And at GM, we see 2 ways that we can help with that. First, by using our deep battery expertise and to support grid-scale energy storage. And second, by turning every GM EV on the road into a distributed power resource that draws energy from the grid when demand is low and pushes it back when demand is high. And we'll talk a little bit more about the scale that we've built in our EV portfolio that can help that at a much larger rate than I think is widely understood. And we'll pull back the curtain a little bit on both strategies today. But to understand how we contribute to a stronger grid, we have to start with our fundamental work in cell chemistry. And Kurt will come up here after me and talk a little bit more about that. But in pack development, vehicle engineering, and cell chemistry, GM takes a little different approach from others in the industry. We match exactly the right cell chemistry, exactly the right cell type to exactly the right application, be that a vehicle, or as we'll talk about today, grid-scale energy storage. Instead of relying on a single cell type, like we've seen in high nickel or lithium iron phosphate, we pair specific chemistries with specific products based on their characteristics, be that their weight, their energy density, their range, their thermal properties, and their cycle count. And we do fundamental research into new cell chemistry development. And we'll talk a little bit more today about some of the research we've done. For instance, in our vehicles, we've invested heavily in a new cell chemistry called lithium manganese rich. We'll talk about this a little bit. Some of you may have written about it. It shaves thousands of dollars off of a EV's cost without immediately compromising this range. Over the last year alone, we've coated more than 3.5 tons of captive material for LMR, lithium manganese rich cells. We built large format prismatic cells with 8 new prototype varieties, and we tested them to the equivalent of nearly 2 million miles on the road. We're on track to commission our first production validation LMR cells when our battery cell development center opens later this year. Now, this intense foundational work in chemistry and engineering is already moving people on Earth. And fun fact, and we threw this in here, this slide has been a little bit kind of out of the way, but NASA has just selected GM's battery technology to power the Lunar Outpost Pegasus rover in their Artemis mission that launches in just 2 years. That's kind of fun. It's kind of cool. We're excited about it. Team's excited about it. It's proud moment for GM. GM has been to the moon before with NASA. This takes us back there. And I think it's a testament to the faith that NASA and others have in the fundamental research that GM does every day on some of these battery cells. Now, back on Earth, we're applying the considerable battery expertise we developed, not just to mobile products, but to stationary ones. We're going to talk a little bit more about what we're doing there. We'll start with grid-scale storage. So right now, our second life battery tanks are already powering the largest microgrid in North America, supporting one of the world's largest AI-optimized data centers at Redwood's installation in Sparks, Nevada. Today, we're thrilled to announce that we're developing next-generation sodium-ion cells, purpose-built for grid-scale storage. Sodium-ion can perform across a wider range of temperatures and for more cycles than other common chemistries. It requires no active cooling and much less system complexity. As such, it's a battery chemistry designed specifically for stationary applications, not for the grid. And you'll hear a little bit more about this a little bit later. Now, all of this work in cell chemistry, in energy density, and cost breakthroughs and second life capabilities, building a future where GM's products fundamentally change the way we think about energy. That includes how we think about our cars. Right? You may have heard me reference cars as the most useful, most complex robot most of us will ever own. What it also is a massive distributed power resource, energy resource for the grid. In fact, as many of us know, most of these vehicles sit idle 95% of any given 24-hour day. That idle time can be used as distributed resources or reservoirs for the grid if they have this bidirectional charge capability. And that's something we've invested in across our entire fleet. And it solves fundamentally new challenges, entirely new challenges for the world. Today, we have more than 250,000 bidirectional capable EVs. That's over 3.5 times the size of what are supposed to be better in that capability. We got high energy density batteries, onboard computing, sensors, and connectivity. And as such, these EVs with this bidirectional charge capability everywhere they are in the world have become a compelling platform for distributed energy that supports the electric grid. Right at the edge, where the inference is ultimately going to move, we've got these power resources there to support. Take the Silverado EV work truck as an example. This truck carries over 200 kilowatt hours of battery, bidirectional battery capacity. When you pair it with our GM energy system, it's been offload enough copper, enough energy to power the average home for approximately 5 days, or 5 homes for 1 day, 10 for a half, I suppose. The Silverado isn't the only vehicle that can do this. Every single GM EV we sell today is capable of bidirectional charge. The Chevy Equinox, Cadillac Escalade IQ, GM offers the largest EV portfolio in America today. Now, we open today by talking a little bit about the grid under pressure. Data centers is energy at an unprecedented scale. The answer to this challenge is a smarter, more distributed infrastructure built from assets we already own, that already exist, and are already part of our everyday life. We've quietly positioned GM and our fleet to do that. The 250,000 EVs on the road, the right battery for the right application, bidirectional energy flow, and software that connects your home, your vehicle, and the grid in one single intelligent system that we'll talk about here in a minute. So to do so, let's talk a little bit more in depth about some of the things that I just introed. I'm going to introduce a couple of people to the stage. First, Wade Shefford, VP of GM Energy. We'll share our progress on vehicle upgrade and take you inside the software that connects your home and your vehicle to your energy life. Then for Caltier, VP of Batteries, we'll take you inside the chemistries that power all of this and some of our future plans for the development. For those who don't know Kurt, he's the ultimate authority on batteries. If you've worked long enough in the industry, you've probably called on him at some point for advice. After Kurt going to speak, we'll close with 2 special guests whose work sits at the center of the energy transition. First, Patty Poppy, CEO of PG&E, one of the most important energy companies in the country, in the Jay Gistro, personal friend, former colleague, co-founder of Tesla, and CEO of Redwood Materials, founder and CEO, I should say, of Redwood Materials. Patty and JB will talk to us about how this new energy economy is taking shape and where GM, PG&E, and Redwood Materials fit in it. So without further ado, let me welcome Wade Shefford, and we'll talk to you a little bit about the GM energy work.
Oh man, that's great to be here in San Francisco, one of the nation's best EV markets. It certainly says that GM is building EVs for every need and every budget. We're also obsessively committed to building an ecosystem around them. We have a once in a lifetime opportunity to reshape how drivers interact with their vehicles and turn them into something more than just transportation. That's why we launched GM Energy, to build a team singularly focused on making every aspect of EV ownership simple and rewarding. To do this, we're building charging infrastructure and systems that give EV owners peace of mind. And we're making great progress. Let's start at home, where most of the charging happens. Today, many GM EVs can do more than just store energy for driving. They can actually return energy to a properly equipped home during an outage. This makes that vehicle battery a source of backup power. The core technical idea here is bidirectional charging. That same capability points to a bigger opportunity beyond the home. Bidirectional charging can help shift energy use across the grid by drawing power when supply is high and send it back when demand is high. This is real. EVs start to matter, even for those that don't own them. Vehicle to grid, also known as V2G, can put money back in their pockets. It also has the potential of reducing costs for everyone by continuing to balance the resilient grid where demand spikes are managed in absolutely new ways. And so today, I'm excited to share that GM Energy's bidirectional chargers are officially now ready to support V2G. Yeah. No new hardware is required. Yes, thank you. Absolutely. So thank you, Bill. And if you own the right GM EV and your home energy system, your car, and now help power your life and support the grid, that's huge. GM already has 250,000 bidirectional EVs on the road. Together with utilities, we have the collective capacity to help balance the energy load across the nation. Right now, we're finalizing utility partnerships and grid protocol to ensure this technology is seamless and accessible. In fact, the beta serves as a prime example of this collaboration in action. Alongside PG&E, we've set an ambitious load target. By 2030, we expect up to 130,000 of our EVs to be on the road in PG&E's territory. Yeah, there we go, Patty. And the goal is for 52,000 of them to be actively supporting the grid. And to put that in perspective, that represents enough energy to power every home right here in San Francisco for more than a half a day. At our Milford Proving Ground in Michigan, engineers walk 15 million miles a year to ensure our EVs are ready for the road. Now, energy innovation requires the same level of rigorous validation as vehicle engineering. So we've established a pilot program with DTE Energy where 30 of our GM employees are using their own homes, vehicles, and GM Energy systems or GM grid engineers to simulate demand response events. That's happening right now. By acting as super users on the Michigan power grid, they're providing high fidelity data we need to ensure that these energy services are reliable and ready for the public. Now, that's great if you're at home, but what if you're out on the road? Well, right now, if you want to drive cross country, we all know we have 5 or 6 different apps, right? Different accounts. And sometimes you're standing there at the charging pedestal in the rain, just praying that card reader is going to work. That's a software problem. And at GM, we decided to solve it by becoming the ultimate integrator. Today, we're launching Energy Pass. Energy Pass is built directly into our vehicles and mobile apps, My Chevrolet, My Cadillac, and My GMC. Here's how it works. Imagine you're an Equinox EV owner using your phone to heat your cabin. Now you can also use that same app to charge anywhere with no friction. At launch, Energy Pass integrates Tesla superchargers, Iona, Electrify Mirror, and soon ChargePoint and EVgo. That's nearly 70% of all DC fast chargers in the country, accessible through one single interface. And this also includes many level 2 chargers as well. That experience is meant to be simple. You set it up once and it just works. You have one payment method, one place to start and end sessions, and one place to view your receipts, your charging history, live status updates, and absolutely, how about those discounts? At some charging stations, you won't even need to touch your phone. Plug and charge functionality lets you pull up and plug in. The charging session, it just starts automatically. Your GM account authorizes it. The Energy Pass handles the billing. We already have this live actually with Iona, Recharge Reason, and UV So this summer, we're bringing that same exact experience to ChargePoint, as well as Tesla Supercharger for vehicles with the NACS native charge ports. We were amongst the first large automakers to rally to create a single North America charging standard. The Cadillac Optic and the Chevrolet Bolt already have transitioned to that standard. And between now and December, all new 2027 Model 3 EVs in the U.S. across Chevrolet, GMC, Cadillac will go next year. Energy Pass will keep getting better over time because we're going to keep adding more features, more networks, and certainly more value. This technology and these solutions, V2G, Energy Pass, as I just announced, they unlock the full potential of the hardware sitting in our driveways. But we're also thinking well beyond driveways. So to tell you a bit more about pushing those boundaries of cell chemistry and what's next from the next battery platform, let's bring up the battery guy, Mr. Kirk Kelty. Let's give him a round of applause. You're welcome.
All right. Good morning, everybody. I've been in the battery business for a long time, and for over 30 years now, actually. So when I first joined the battery business, actually, we were working on the Sony camcorder and Dell laptop computer. We're just trying to extend, just get a few extra minutes of runtime out of those consumer electronics. But today, we've come a long way. We are now powering full-sized electric trucks that deliver more than 450 miles of range on a single charge, while offering an EV for every kind of customer. We go from an affordable Bolt, the Chevy Bolt, you see it right here, to a long-haul towing vehicle like the GMC Sierra EV that you probably walked through when you came in here. This evolution is really nothing short of amazing. And because batteries can already do so much, we're aiming even higher. When Wade talked about unlocking hardware, he wasn't just talking about cars. We're using our battery technology infrastructure to tackle a much bigger challenge. Today, electricity demand is growing at a pace we haven't seen in generations. Data centers alone are expected to triple their share of U.S. power consumption in just the next few years. The U.S. needs more reliable and affordable energy. Batteries are a critical part of this answer. What we've done at GM in prototyping, testing, and scaling batteries for the road has given us an innovation engine that the country now needs to help power the future of our electricity system. For energy to stay affordable and reliable, the battery in your driveway and the battery powering a data center have to be part of the same conversation. So we're applying everything we know about battery technology to help strengthen the grid itself. Today, I'm excited to share how GM is flexing these capabilities to help meet rising energy demand in a rapidly changing grid. Our strategy is simple: develop the right battery for the right application. This means using every advantage in our innovation arsenal with discipline, matching battery chemistry and form factor to what each use case demands. For energy storage, that starts with solutions we're putting to work now, while building towards the next generation of batteries we believe will reshape the grid. Together with Redwood Materials, we are already deploying roughly 10,000 GM Second Life batteries into real-world energy infrastructure. That includes Crusoe's AI data center in Sparks, Nevada, the largest Second Life battery microgrid in North America, with additional deployments ahead at AI data centers. The benefits of using these systems extend into all types of industrial settings, including our own manufacturing footprint here in the U.S. Starting next year, we plan to deploy Second Life battery packs at our own operating plants, starting with a site in Michigan. We'll install roughly 100 GM second life batteries to provide 7.2 megawatt hours of dispatchable energy to the plant. We expect to save over $3 million over the lifetime of this project. It's a great example of how we're maximizing the value of batteries today, and we're proud to be the first automaker to partner with Redwood on the full battery life cycle, from recovering manufacturing scrap and recycling to end-of-life packs to now deploying repurposed energy storage, including at an active manufacturing plant. Now, we're also moving fast through our Ultium Cells joint venture with LG Energy Cells, with LG Energy Solutions to help meet our near-term demand for grid-scale energy storage. Within the month, Ultium Cells will begin producing LFP batteries to serve LG Energy Solutions' commercial energy storage business, showing how we're leveraging our existing footprint and manufacturing know-how to deliver energy storage solutions on the grid quickly. But when we look at where stationary storage is going, it's clear the grid needs more. We need more innovation, more flexibility, more value for every battery it deploys. Because if you ask utilities, data centers, and other power providers what they need from an energy storage system, the answer is pretty clear. They need it to be affordable. They need it to be safe and durable. They need it to last a long time and perform in the real world across a wide range of conditions. And they did all that with less maintenance, less complexity, and lower operating costs over time. At GM, we know the application should determine the battery. That's how we approach EVs, and it's exactly how we're approaching stationary storage. So when we look at the ideal battery for the grid, one that can help deliver safe, reliable, affordable, and low-maintenance energy storage at scale, we believe that future is sodium-ion. And today, I'm excited to announce that GM is developing next-generation sodium-ion battery cells for grid-scale stationary storage in partnership with Peak Energy and backed by strategic investment from GM Ventures. Sodium-ion is an ideal battery chemistry for the grid, and Peak is already demonstrating its value through their innovative energy storage platform that lowers operating costs and increases reliability for customers. Peak system harnesses the strengths of sodium-ion, and together, we're advancing that foundation with a next-generation cell that we're developing in our labs to deliver even greater value for utilities, data centers, and other power providers. That matters because advances at the cell level can translate into meaningful system-level benefits for stationary storage. Sodium-ion can perform across a wider range of temperatures and for longer than incumbent chemistries, with the potential for less cooling and less complexity than other grid-scale batteries. That translates to significantly lower operating costs over the lifetime of the program. And because sodium-ion cells share potential similarities with lithium-ion, we are applying our expertise in cell design, in prototyping, and industrialization here in the U.S. to help commercialize this new technology. But what really excites us about sodium-ion is how much headroom remains. We believe this technology still has significant room to improve, pushing it to the cutting edge of performance in this class of chemistry. Our next generation sodium-ion cell development will drive energy density higher and cost lower, with the potential to outperform more mature chemistries over time. That long-term potential matters. Sodium is one of the most abundant elements on Earth. It's in table salt. And that gives us pathway to more affordable materials, lower costs, and greater supply chain resilience as we build storage at scale over the long term. That's a real differentiator for us. We're not licensing somebody else's technology from China. We're building on GM battery know-how in America for a grid market that needs durable, cost-effective storage at scale. We're excited to have Peak Energy's co-founder and CEO, Landon Mossberg, here with us today as we share that ambition. And I'd like to welcome him on stage to share a few words.
Thanks, Kurt. Thank you, Kurt. And Peak is proud to partner with GM as we jointly propel the next era of American energy leadership. Peak Energy has already upended the energy market by targeting the leading cost drivers in energy storage. And our groundbreaking technology eliminates all cooling, moving parts, regular maintenance, and lowers energy storage costs by 40%. Our passively cooled system can reduce energy waste across the US by over 2 terawatts a year just by eliminating the cooling systems. And by combining T system expertise with GM's battery experience and industrialization stream, we have an opportunity to shape the next generation of sodium ion and grid scale energy storage technology and help Americans expand energy access to practical scale energy storage. He is proud to be solving America's most pressing energy problems, and in partnership with GM, we look forward to building the next generation of energy storage to further the progress. Thanks.
Thank you, Andy. So you can see why we're excited to work with Peak Energy. It's the performance is fabulous across total cost of ownership. That is the real focus here. Now back into GM, we built a centralized battery R&D engine in Warren, Michigan to power these breakthroughs. There we're advancing chemistries like LMR, green bees, and this year we're prototyping sodium-ion cells purpose-built for stationary storage. You'll be able to see some of those in the side here afterwards. Our new Battery Cell Development Center, launching this year, is the critical bridge from the lab to production, where we validate and industrialize new concepts before scaling them. We expect the first mass production grade sodium-ion cells to come out of this facility in early 2028. Every improvement we make here, whether for EV cells or ESS cells, flows the same battery development staff, deepening the capabilities that support both businesses. This is what the right battery for the right application looks like when we put it in practice. We're deploying second-life batteries with Redwood and LFP where that makes sense today. And we're investing in sodium ion because we believe it can become the defining chemistry for grid scale storage. At GM, we built deep battery expertise here in the US with the technical capability, the talent, and the infrastructure to help position GM as America's battery leader. Now we're using it to help shape the future of energy, aiming to extend our leadership from the vehicle to the grid to create a more resilient electricity system for the AI era and beyond. Thank you. Now, for the next and last segment of this portion of the event, I'd like to bring to the stage two very special guests. As much as I love to talk about battery technology, and I can probably talk about this for hours, but these solutions don't exist in a vacuum. They have to plug in to a physical reality. In California alone, PG&E is seeing a queue with over 10 gigawatt hours of interest from new data center projects. That's a staggering amount of demand. The question is, how do we connect that road without compromising the reliability and affordability that every homeowner and small business depends on? To talk about the intersection of big compute and grid stability, I'm thrilled to welcome someone who's currently leading the transformation of one of the largest and most complex energy systems in the world, the CEO of PG&E, Patti Poppe. Now, Patti has been vocal about the fact that every new gigawatt of data center load can actually reduce rates for everyone else if we get the integration right. And joining her on stage is someone who has helped shape the modern battery industry from multiple angles, from EVs to battery materials, and now to energy storage. As founder and CEO of Redwood Materials and a good friend of mine, Jamie Stauble is now focused on how batteries can help meet surging power demand with fast, flexible energy storage systems built here in the US. Redwood is already working with GM to put our second life batteries to work in energy infrastructure, and together we're expanding that collaboration to pair GM batteries with Redwood's energy storage system. Please join me in welcoming the CEO of PG&E, Patti Poppe, and the CEO of Redwood Materials, J.D. Song.
Thank
Welcome.
Yep.
It's exciting. I'm really excited to be here with both of you. And I was just talking to JD while we were just sitting down there. The excitement of the three of us and the intersection of our industries. And I just loved hearing JD talk. I always love hearing JD talk. But if you could share your thoughts that you're just sharing with me, I'd really appreciate that.
Well, it's great to be here again. Thanks for having me, and excited to be part of this discussion. I was reflecting that, having all of us together on the stage is just, it's really simple of kind of the moment we're in, where we're blurring together this distinction between automaker, EV, energy grid, energy supply, and then battery ecosystem, which I, am so passionate about. And we've kind of dreamed about that for a long time, but it's really, we just feel it happening.
It is exciting. I'm happy to, so my job is to ask you guys tough questions. So, and I'm already prepared. So before we get into the big picture here, so each of you has helped shape the transition from a very different angle. What still excites you most about EVs and why? We'll start with you, Patty.
Well, they're fun to drive. I mean, Denali out there has my name on it for sure. But I think, people ask me all the time about the grid and aren't EVs going to strain an aging infrastructure? I'm here to set the record straight. Our grid desperately needs EVs, particularly bi-directional EVs that we can optimize and contribute to the grid. It's the first flexible demand there ever has been. So if you think about light bulbs come on when it's dark, air conditioners come on when it's hot, factory motors come on when the factory starts. EVs can charge at the optimal time. It's the first demand that we can optimize and then provide supply back to the grid. It's extraordinary. I've been waiting for this time and this day. And so I couldn't be more excited about the power of GM's projects and GM's vehicles powering the grid.
I love hearing this from a utility. This is fabulous. Jamie, do you want to add anything more?
It's always tough to choose. There's so many pieces of EVs that I'm passionate about, but I think, I would say the energy flexibility is just phenomenal. The EVs have been, from their inception, this chance to be a path to decarbonization because they can fundamentally use all different sorts of energy delivered through the grid. And the second piece that's maybe less intuitive is just the materials ecosystem around an EV and its use and footprint on the environment is so different. And this is where recycling and thinking about the life cycle of battery could be totally different than the petroleum life cycle. We're not using any materials, in the long term. They can be reprocessed and rebuilt, very different than the hydrocarbon type of fuel economy.
Yeah, and JD and I have talked about this before, but like 20 years from now, 30 years from now, it's going to be a complete closed loop system, essentially. We won't need to mine any new nickel or lithium. It'll be already there. We just recycle it, put it back into new batteries.
Or sodium.
Yes, that's true too. Okay, let's move next. So for a long time, the energy conversation was centered on cost and the pace of the transition. Now the stakes feel different. Reliability, speed to deploy, industrial capacity, and surging electricity demand are all colliding at once. From where you sit, we'll start with you, Patty. What's most fundamentally different about this moment? What kind of playbook does it require?
Well, first and foremost, this your demand curves that were talked about earlier, the Wade shared. Look, this demand is real. It's happening. And we weren't, any of us in this business running the grid have not seen this growth in our careers. Nobody's done this before. And the cool thing about what we need to do now, though, is obviously speed to power. We need to make sure that the grid is safe and affordable. And what I'm excited about the new demand is part of what drives rates up is lowering demand over time, which in many cases and on my grid has occurred. We've lowered usage through energy efficiency and rooftop solar and using less power has actually raised rates. And so for the first time in my career, I get to actually add demand to the grid through EVs, as well as large industrial loads, onshoring manufacturing, as well as obviously data centers. That allows us to start to more fully utilize existing infrastructure. That's the first job. We shouldn't be rushing to build new stuff when we can better utilize stuff we have already built. So that's thing one, and batteries enable that to happen. And then two, do it in a more integrated, technology-enabled way. So we've initiated a new playbook of doing simultaneous engineering using AI to optimize grid placement, grid utilization, and what the right resources need to be at the right places so that we can have the lowest cost addition. So we're seeing every gigawatt that we can add to the grid will lower everybody's rates 1%. We have to get the pricing right. And there's lots of people trying to get a piece of that market. And I'll just tell everyone today, you just have to get the pricing right and make sure that we've optimized and fully utilized all of our existing infrastructure and then add the new stuff wisely. And I think we are definitely at the forefront of that at PG&E, and we are off to the races. You talked about the 10 gigawatts of applications that we have flowing through our system today. Just to put that in perspective, San Francisco is a 750 megawatt city. San Jose is a 1 gigawatt city. We're talking about adding 10 gigawatts of demand. That's extraordinary. So getting it right and using technology to enable us doing that at the lowest cost is the best thing that could happen to this grid, because in the absence of this new demand, which brings new revenue, all of us, those who live in the Bay Area here, are going to pay for rebuilding aging infrastructure. In this scenario, our infrastructure can be powered and paid for by new demand and new revenue. This is a great opportunity, certainly here in California, and the PG&E grid's ready to go.
Well, I love hearing your optimism, Patty. This is great.
Well, it's based in facts. So
Yeah,
that's good news.
no,
It's just optimism.
No, it's
Yeah.
great, and I wish all other utilities thought this way as well. It's fabulous, as it is based on facts. Yeah, Jamie, you want to add anything to that?
Well, I would echo that the demand growth is nationwide. It's really, global even. And we feel it every day from customers trying to come to us, for energy storage and stationary energy storage. It's part of why I'm so excited about being able to deploy repurposed and second life batteries really quickly, because the stuff is acute. I mean, the demand is sort of yesterday. People want a new industrial facility online immediately. And we've been able to repurpose gigawatt hours of storage with you and others, and be able to meet a significant chunk of that demand very, very quickly. So to me, that's an exciting way to do this with urgency, but also a lower environmental footprint with a very sustainable solution, and a very cost competitive solution. Because ultimately, when you can deploy storage, that's been part of this whole life cycle in an EV, and then ultimately recycled, we can reduce the actual cost to the users even more.
And then after recycled and then reused again, back into batteries, back into vehicles. So, it's an exciting story. All right, Patty, that's you. One of the ideas behind today's conversation is that the battery in your driveway and the battery supporting the grid are no longer separate conversations. What has to happen in technology, in infrastructure, in market design to make that vision real at scale?
Yeah, well, first of all, let's just kind of give some perspective on the scale. Today in PG&E service area, we have about 850,000 electric vehicles. That's the equivalence of 550 megawatts of both demand and supply, which is so incredible. And so our work that we're doing with GM, our goal, as Wade shared, is to have 130,000 GM EVs in our service area. That's 85 megawatts. And we're excited about that. Our first goal is to get 52,000 of those working bidirectionally on the grid. And so what's really required is we have to have visibility to see these resources. The grid operator is a very important ingredient in this equation. I think there certainly is a vision for a more distributed energy system, but if that distributed energy system is operated in a sub-optimized way, which I would argue is true today, all of our distributed resources act independently. They are not integrated. They are not optimized. It is a higher cost grid than could otherwise be possible if you have a grid operating system. And we've implemented a distributed energy resource management system that enables us to see and control devices across the grid that will enable us to utilize them in the right place at the right time. The grid is a big integrated system. It is connected across the entire world, but it's certainly in North America is a connected, integrated system. We must optimize and maximize the utilization of that. I'm an industrial engineer, so I cannot help but see when there's waste in the grid. Our grid today is utilized about 45%. And so we're rushing to add a lot of capacity, but what we need to do is add capacity and integrate it in such a way that we can maximize the utilization of it. And that's the pathway to lower bills for everyone and a more resilient system that can shift and be nimble during changing weather conditions or changing environmental conditions.
Yeah, no, that optimization is absolutely critical where we are now. JB, I want to probably put another question that I really would love to get your insight on. You've said that batteries need to be treated like strategic national infrastructure, something I also advocated for. What would it actually take to get there from where you sit? Are we moving fast enough?
Well, I think we've taken big strides, but I'd say we aren't moving fast enough. And if I look at what some other countries around the world are doing in particular, I mean, China's always the foil against this. They're moving incredibly fast, faster than we are. And, I believe that the batteries and energy storage on the grid and in our whole infrastructure of transportation and energy, will become one of the most sort of critical enablers. Today we look at substations and transformers and power plants kind of that way.
All my favorite things.
Defended and protected. And, I think if we fast forwarded a few decades or hopefully less in the future, batteries and the energy storage elements could be the thing that should be the most strategic piece of how the grid operates. So to me, this is going to take consistent policy, which we haven't had in a long time, but really consistent industrial policy across the whole country, that prioritizes the whole ecosystem to make this happen, the stability and sort of the financial landscape to promote it. It's happening naturally in California to a huge degree. California is kind of the leader in this, but it's in different degrees and for different reasons around the country. So anyway, I'm very bullish on this. I think this is where things are headed, whether it's driven by policy, driven by economics, or some of both. But I wish it could happen faster.
Well, and if I can just pile on here, and just do a shout out for California. I think there's a lot of people who might be surprised to know that here in California over the last 5 years, we have added 33 gigawatts of capacity to the California grid. 33 gigawatts. The peak in California is 50. We've added 33 incremental gigawatts in the last 5 years, 13 of which were battery storage. And that battery storage on I think it was March 27th, actually powered the entire grid for 4 hours through the peak. That's the first place in America that you had full battery storage powering the entire grid for 4 consecutive hours. Yeah, go California. And so we're excited about that. The good news is we got 22 gigawatts more coming online. So I think people think it's hard to build in California. Nobody must be doing that. That is just a big myth. We are building in California. We are adding capacity, and that capacity has been able to keep up with the growing demand, and it's going to be able to serve then. And that's why we can serve this new large capacity demand that's coming our way. That it is very timely, but we've got a good planning system, believe it or not, here in California that actually delivers that kind of capacity growth. We do need to go faster. I totally agree, but very proud of the progress California's made.
Oh, I love it. We got to share the wins.
Yeah, come on.
That's a win. So, all right. Last question. JB, I'm going to go back to you. GM and Redwood have been working together for a few years now. When you look at how this partnership has evolved, and what does it tell you about where the industry's headed?
Well, I think as you highlighted at the outset of the talk, I mean, this is such a cool example of the battery ecosystem in action. It's sort of the vision that you and I, in some degrees, had talked about many years ago, where we've sort of evolved it from scrap recycling and an end-of-life battery recycling into materials, availability, now into second life, repurposed energy storage. And it's linking all these different things together with the battery and its materials as a central theme. So to me, that is where the industry's heading. I think GM and, humbly ourselves, I think we're all leading this and having a chance to really define what this will look like at even bigger scale in the future. Because even as successful as EVs are in California and for GM, it's still a beginning. If you look at the percent of the fleet on the roads today, it's still way less than half. I mean, way less than even 20%. So we have, 5x, doubling to come in the future on just the scale of this whole thing. So I'm excited that this ecosystem linking together, repurposing, recycling, remanufacturing, and station energy storage really is how the EV ecosystem will be deployed.
Yeah, no, total agreement. Now I'll trick you because I said that was the last question, but it's not. We're actually going to do a rapid fire lightning round. So I guess not technically questions.
Before we do the rapid fire, I'm
Yes.
sorry. Can I just tell a quick story to make it really?
Yes, please.
I just love to share the story about the leadership of General Motors in this environment of the bidirectional charging vehicles. At PG&E, we are faced with the daunting task of preventing wildfires and making sure that our equipment does not do harm. And so we've been on a massive reinvention of our company and our grid to make it safe. And one of the tools that we use, reluctantly but necessarily, is something called enhanced power line safety settings. And what that means is that we have to de-energize the grid when we know the conditions are such that a wildfire could be possible. And so between our public safety power shutoffs and enhanced power line safety settings, we have to shut off the power to customers. And I had been at PG&E for a couple years and was very clear in facing this daunting challenge here. And I called Mary Barr, and I said to her, she and I have been friends for a long time. I worked at GM for 15 years, and we've known each other our entire careers. And I called her and I just said, look, Mary, I need your help. I need a bunch of these EVs to be distributed across this grid so that I can keep people safe, but they can still have power. And that's what's possible with what GM is doing. And she, that day, said to me, we are on it. And we put our teams together, and they've been working side by side, hand in hand. And so today is a very special day for what GM is doing for the world and to keep my customers safe. Thank you.
Thank you. Those help better. Well, let me get back into my rapid fire.
Rapid fire.
Yeah. So real quick here, what's one thing the industry needs to move faster on? JV, we're going to start with you.
I'm going to start up fast. I would say, I would have said fast charging network, but it sounds like there's some progress being made on that. But I would still put that on there.
Yeah. Sorry.
Ease of use for ubiquity of it.
Yes. So
Interconnection studies. Okay, I know it sounds so wonky. It takes us too long to decide where to
Yes.
put what infrastructure.
Absolutely.
It's too long, and we're using AI to accelerate that.
yes.
Please, Dad.
All right. Second one. We only have 3 of these. What's the most underrated energy asset in the system today? JV. Yes, that's the right answer.
I think that's more specifically EVs. I think more.
That's a good one too.
Yeah.
Man, you guys are on this. Okay.
Clear.
The last one. And you can use the same answer twice. One word for the next chapter of the energy transition. JB, over to you. You can't.
What? Sorry.
You can use the same word twice.
I was going to say exciting.
Oh, exciting.
Exciting.
About that. Oh, exciting. Yes. Okay. Good.
Affordable.
Affordable. That is critical too. Yeah. You need both these things. All right. Thank you both. Really appreciate your involvement here and your contributions. Thank you very much.